We're going to take a look at 4 basic functions. 3 of them we're going to look at in other units also, but we're going to use these 4 to just explore the different transformations and how to use them with graphing so that you're good at this when we get to those other units. First, we're going to look at the absolute value function. And with the absolute value, just making the numbers positive or keeping them positive. So the key when I say to memorize here is it's really these x values that you want to know. And for 3 of the 4 functions, you're using the same 5 x values, -2, -1, 0, 1, and 2. So if we take the absolute value of -2, it's 2. Absolute value of -1 is 1. And then 0, 1, and 2. So although you need to memorize them, you can kind of generate these tables pretty quickly if you remember what these functions mean. And then the general shape for this is going to be a V shape, so you should know that also, just so when you plot the points you know what to finish up graphing. And it has a vertex, and that vertex will reflect your translations left to right, up or down. And that's going to happen also with the squared function or the quadratic function. So with the quadratic, again, notice you're using -2, -1, 0, 1, and 2. If we square numbers, they become positive. So 2 squared is 4, 1 squared is 1, 0, 1, and 4. So repeating again, unlike the absolute value, though, it's not that V shape, it's going to be a U shape. But it also has a vertex. Okay, and the other 2, we have the cubic function. This one is going to kind of reflect the beginnings of the polynomial functions when we get to that unit. It's a little curvy. It doesn't have the vertex point, but it does have the point in the middle where the curves kind of change direction, and that's called an inflection point. That's where your transformations are going to go. Cubing, the numbers that are negative will stay negative, and then the other ones will be positive. So 2 cubed, or 2 times 2 times 2 is 8. 1 cubed is 1, and then these will be the positive versions of those answers. So again, same starting 5 values, but then you just have to cube them. This one's a little different. I'm going to start at the square root function. Square root function is going to look like this. It's like half of the quadratic function, which is right up above it, just turned on its side. Notice we have different x values here. We're going to do the first 4 perfect squares. I don't know why it's not letting me right there. We go. And then you'll just square root each of those numbers. So square root of 0 is 0. 1, square root of 4 is 2, square root of 9 is 3. So we're now going to use these different starting graphs and do some transformations with them. We'll take a look at one in this video, and then we'll look at the other 3 in the next video. Okay, so we're starting out with the absolute value. Our parent function is f of x equals absolute value of x, which it will ask you for this on the worksheet. So again, the transformations are going to come from not the parent function, but everything else surrounding it. We have the 2 in front is a vertical stretch by a factor of 2. And I'm just going to put multiply y values. A y value, so I can let's make that a little bit better. So we're going to multiply the y values because it is vertical by 2 when we go to work with the table. The x minus 2, which is technically our parentheses, is going to be a translate right 2. We're going to add 2 to the x there. And then we're going to do the 3 plus 3 is a translate up 3, so we're going to add 3 to the y column. So unlike graphs that you saw before where they were just given to you in picture format, you can pull points off. Here you have to generate your own starting points, so we're always going to start with these, again unless it's square root. Using the parent function, okay, so that's the parent is going to be going with your original table. You're just going to come up with those original values. And then what you're going to do here is we're going to do first a stretch or reflect table. You have to do them in that order. So it's kind of like order of operations. You multiply, then you add, subtract. So your translate table you're going to do last. First thing we're going to do is multiply the y values all by 2. That's our first transformation, or the vertical stretch. So vertical y values. Once you do that, you're going to get a new table that you're going to then add or subtract to. I'm going to try to write a little smaller so we have space to write the adding, subtracting underneath. So we get 4, 2, 0, 2, and 4. Now we're going to take that result. The right 3 is your x value, so I'm just going to put x next to this and y next to this. That's what you're going to be adding or subtracting to. If it's right, you're adding. If it's left, you're subtracting. If it's up, you're adding. If it's down, you're subtracting. So normally what you would think in terms of those expressions. So we're going to do plus 2 here because we're going to the right 2, and we're going to do plus 3. That's going to give us our final table so that we can plot those points and get our transformed graph. So we're going to get 0, 1, 2, 3, 4. Now it's also easy to see with the 3, the middle point or the vertex point is going to be your 2 transformations, so that's kind of a nice thing. And then we have 7, 5, 5, and 7, and it's symmetrical. So again, this middle point, if you look at the vertex point, those numbers should match up with your transformations. And then we're going to plot them. I like to plot these starting with the vertex because it is symmetrical, but you can just plot them in order also. So I'm going to plot 2, 3 first. Then I'm going to plot 1, 5, and at the same time plot 3, 5 because they're right across from each other, and then 0, 7, which is like right at the top, and 4, 7. And I unfortunately put this up a little too high, so it's not letting me do that. You're then going to connect this and put arrows at the end. You're just going to have to get that last point on there. I'm not able to get it plotted because I put this too high up on the screen. And that's it. That's your final graph. So you have your table to match with it. If you can do some of these transformations without doing every single table, you at least need to have the final table and your graph. So again, the next video we're going to do some other graphs with the transformations, but the process is always going to be the same. You just might have a different starting table.